Hello everyone, welcome back to my classroom. Our today's topic will be the heart electrical conduction, the electrical system of the heart. But before going further, let's discuss the brief introduction about this electrical system. For the heart to work effectively, both sides of the heart have to work together. We mean simultaneously. That means both atria should contract simultaneously. Both ventricles should contract simultaneously, as well as they should relax simultaneously. The atria and the ventricles should be coordinated to contract and relax at the same time on both sides of the heart. Each chamber of the heart contracts when an electrical signal moves through it. Of course, a chamber contracts due to the electrical impulse that has passed through it. Basically, the atria contract first and pass blood down to the ventricles, and that followed by ventricular contraction to eject blood to the lungs or to the system. We may wonder, where does this electrical signal come from? Of course, it's a very important question. The electrical signal is generated from a specialized cell situated at the upper portion of the right atrium, called the sinoarterial node, the SA node, which is sometimes referred to as the heart natural pacemaker. It is a specialized cell that generates the heart electrical impulse naturally, without no external factor, without no influencing factor. As the sinoarterial node generates this electrical impulse, this electrical signal travels across the heart, depolarizing the heart muscle, causing them to contract. Now let's go down to this conduction part. The sinoarterial node creates the electrical impulse. Of course, there is a path this electrical impulse follows to depolarize the myocardial muscle to generate myocardial contraction. We know, and we already talked about the sinoarterial node, the natural pacemaker of the heart that generates the heart electrical system. The sinoarterial node creates the electrical impulse. The electrical impulse travels across the atria in the first place to create atrial contraction for blood to be pumped from the atria to the ventricles. This signal that is created by the SA node travels along a path called the internodal tract, which distributes the signal, the electrical impulse, across the atria for them to contract. And we'll take a look at this internodal tract in the upcoming diagram. The atrioventricular node, the AV node, of course, is another spatial node situated mid between the atria and the ventricles. In other words, it is sometimes referred to as the collecting node because it collects the impulse that travel across the atria and suppress their transmission down through the bundle of his. And we have bundle of his. which is a spatial bundle that conduct this electrical impulse down the cardiac septum to be distributed into the ventricular myocardium to create ventricular contraction. The bundle of his branch into two main branches, the left and right bundle branch, each leading to the left and right ventricle and rooted into the ventricular myocardium, the muscular layer of these ventricles, and creating a finger-like projection called the Purkinje fibers. And together, they depolarize the ventricular myocardium to generate ventricular contraction. So let's take a look at this conduction pathway here from the diagram. We said earlier the SA node, the generator, the heart natural pacemaker that generates the electrical impulse of the heart. So this spatial node you see in here is the heart natural pacemaker, the sinoatrial node. The sinoatrial node generates the impulse without no other factors. Generate the impulse travels down this track to create atrial contraction to the Bergman's bundle, which branch to the left atrium. We have the middle, we have the anterior internodal tract, we have the middle internodal tract, and of course the posterior internodal tract. And all these tracts converge at a spatial point, the AV node. And at this AV node, the electrical impulse is collected there, and we can see it is situated between the atria and the ventricles. Something interesting happened here because the electrical impulse do not pass down the valve because the valves are made up of fibers made of collagens. And this collagen are insulating, they do not conduct electrical impulse. So the AV node collect this impulse and delay its transmission down to the bundle of phase through the Purkinje fibers to stimulate, generate ventricular contraction. Okay, let's talk about this spatial node, the heart natural pacemaker, the sinoatrial node. The sinoatrial node is a natural pacemaker that generates the impulse at a particular rate without no factor causing or telling the sinoatrial node it depolarize at a particular rate to generate electrical impulse that create myocardial contraction to pump blood to the lungs for oxygenation and to the system for tissue oxygenation and nutrient supply. The SA node ensures that the heart beats regularly and therefore produce a natural rate of generating impulse. It depolarizes approximately 100 times per minute. Some people will say the SA node depolarizes 90 to 100 times per minute, but this depends on entirely how many times it depolarizes. It depends on varies from one person to another. Sometimes people have less than 60 to 100 beats per minute within that duration or within that time, within that normal range. People can have any amount of depolarization that this SA node can make. The sinoatrial node can be modified the amount of depolarization it made can be modified by certain factors like emotion, physical reaction, hormones, especially adrenaline, noradrenaline. These special factors increase the heart rate by causing the sinoarterial road to dilate, to depolarize more at a particular time or minute. Of course, let's move down to the AV node. It's another spatial node, also referred to as the conduction node. The atrioventricular node, AV node, is a node between the atria and the ventricles. It is situated at that point because it ensures its main function is to so that the electrical impulse stays within the region of the atria until the atria are completely contracted and the ventricles have completely been filled with blood. This node is designed to suppress the impulse generated by the sinoatrial node. In other words, it delays the transmission of the impulse from the atria to ventricles. And the main reason behind that is to ensure the atria are completely contracted and the ventricles are completely filled with blood before they contract. The AV node delays the impulse to ensure the atria contract completely and the ventricles are completely filled with blood. This therefore creates the two phases of heartbeat, the diastolic phase and the systolic phase. As the SA node releases the electrical impulse, this electrical impulse travels through the internodal tract and across the atria to create atrial contraction. That's atrial systole, contraction of the atria. What happened at the same time? The AV node suppressed the impulse from reaching the ventricles. And at that point, the atria contract, blood is pumped down to the ventricles. At that point, the ventricles relax. They are filled with blood, and that is a ventricular diastolic phase, relaxation of the ventricles. The AV node releases the signal, allowing the ventricles to contract and pump blood to the lungs and to the system, and therefore cause ventricular systole, contraction of the ventricles. Of course, at the same time, the two atria relax and allow to fill with blood, returning from the lungs that has been oxygenated and blood returning from the system that is oxygen depleted. And at that point, the two atria relax and they are in the atrial diastolic phase. So in general, the AV node collects the impulse, distribute the impulse, create the phases of heartbeat, and is therefore referred to as the collection node. Let's move to the bundle of phase and Purkinje fibers. There are also spatial nodes that conduct the impulse down the way through the cardiac septum to the ventricular myocardium to create ventricular contraction. The bundle of phase conduct the collected impulse from the AV node down through the cardiac septum. It branches into two main branches, as we said earlier, the left and the right bundle branch, each serving left and right ventricles respectively. Each bundle branch continues to spread through the ventricular myocardium, and each projecting a finger-like projection, a group of cardiac muscle fibers called Purkinje fibers. And as the AV node releases the impulse, travel down the bundle of his to the two main branches, the left and right bundle branch, down to the Purkinje fibers, and together the Purkinje fibers distribute the impulse across the ventricular myocardium and therefore causing the ventricle to contract and create a pressure within the lumen of the ventricles to eject blood to the lungs, to the system. So let's take a look at this diagram here and see how this ventricular contraction occurs. But as we talked earlier, the sinoarterial node creates the impulse. The impulse moves across the atria to create or generate the atrial contraction. The atria contract, blood passes from the atria to the ventricles. The signal is collected by the AV node, which delays the transmission of this impulse down to the bundle of his so that two atria can completely contract and the two ventricles can completely fill with blood. As the two ventricles are completely filled with blood, the AV node releases the impulse down, which travels through the bundle of his to the left and right bundle branch, then to the Purkinje fibers, as we see here, and together they generate ventricular contraction and eject blood to the lungs or to the system. So, and we'll have the ventricular contraction phase. Of course, very important question here. What regulates the heart rate? An important factor, very important point, very important system is responsible for the regulation of the number of times the sinoarterial node depolarized to generate heart contraction. The nervous system is responsible for the regulation of the heart rate. It regulates the heart rate in the fact that it increases and decreases the number of times the sinoarterial node will generate electrical impulse. In that sense, it doesn't mean the nervous system will generate the electrical impulse, but regulate the sinoarterial node to ensure that the amount of depolarization the SA node made is within the limit or normal. The autonomic nervous system, that is the sympathetic nerve and the parasympathetic nerve fibers, are directly involved in the regulation of this heart rate. The sympathetic nerve increases the heart rate, while the parasympathetic nerve, the vagus nerve, decreases the heart rate. That's the 10th nerve in the body. Other factors such as emotion, physical factors, hormones can increase the heart rate because they have direct factors on the nervous system. Let's take a summary of the whole electrical system of the heart. Looking at the diagram here, we say the sinoarterial node generates the electrical impulse that stimulates the contraction of the myocardial layer of the heart. The sinoarterial node generates this impulse, and the impulse travels down through the internodal tract to distribute the electrical impulse between the atria to generate atrial contraction. As the atria contract, the AV node, referred to as the atrioventricular node, sometimes called the collection node, collects the impulse and delays the transmission of the impulse down the bundle of His to ensure that the atria contract completely and the ventricles are completely filled with blood. As the two atria contract and the two ventricles are completely filled with blood, the AV node releases the impulse down, which branch into this right and left bundle branch, each routed into the ventricular myocardium and ending into a finger-like projection called the Purkinje fibers. Together generate or create ventricular contraction to eject blood from the ventricles to the lungs with the system. Of course, we talk about the regulation of the heartbeat, the vagus nerve and the sympathetic nerve that are directly attached to the sinoarterial node regulates the number of times the sinoarterial node can depolarize to create heart contraction. Of course, the sympathetic nerve increase the heart rate and the vagus nerve decreases the heart rate. And that's our reference. That's the end. Thank you all for watching. Please do not forget to subscribe and like the video. Thank you.